Welcome back. This time we're going to add our second and third harmonics. So we will have to completely guess the amplitudes of these things. Now I'm just going to imagine that the amplitude of the next one is a bit less, like say 4, and the next one's even less, like 2. Have no clue as to what they really are. And I'll probably just put 0 for the phase angles to start with because I have no better idea. Now, same as we did last time, we want to have the amplitude of this component multiplied by a cosine function, and we need 2 times pi times the frequency, which is 880 for this one, multiplied by the time variable, add on the phase. Lock that one in, close the bracket, and enter. Now we'll do the same thing for this one. We will have the amplitude for that one multiplied by the cosine function of 2 times pi times the frequency, much higher frequency, lock the frequency, multiplied by the time variable, add on the phase for this component. Then I'll copy those two all the way down, and you can see that my model is now changed quite considerably. Still not a good match, but that's okay. I now have a model with 3 components. I could try changing the phases of these things. I could make the phase of this equal to pi. That actually seems to have helped a bit because I've got the smaller bumps now down here and the bigger bumps closer to the bigger bumps. We could guess and check our way through this, but how many different things have we got to guess and check? We've got 7 of them because each of my 3 components has an amplitude that I would need to guess and a phase angle that I would need to guess, plus there's that one vertical shift. Now the frequencies I'm confident about because I know from studying in a physics class that the frequencies should be whole number multiples of the fundamental. So I'm not going to change the frequencies, but how on earth are we going to guess those 7 different numbers and get a good match for our graph? Well, that will be the topic for the next video. Stay tuned.